I am not Steve Moritz, in case anybody is wondering. My name is Rachel Allen. I'm the General Counsel and Corporate Development Officer for Incentive. Steve, unfortunately, is in the hospital, so I have to do this, so bear with me. I'm excited to be here to tell you about Incentive Energy. Our vision is to accelerate the sale and installation of the technologies that reduce our carbon footprint and create a more reliable energy infrastructure. Okay, the problem is there are tons of products on the market, lighting, HVAC, EV chargers, that can reduce our carbon footprint and reduce the stress on the grid. And utilities are providing tons of money to incentivize the purchase of these products. But trying to figure out if your product is qualified, if there's another product that you could use that would be qualified for a rebate, and then applying for the rebate and getting the money is incredibly difficult. Low participation rates, which don't make utilities happy because they really want to give away this money, and it's hard to figure it out, and it's a very paper-intensive process until we came along. And it's a lot of money at stake, $10 billion in incentive and rebates from the utilities, another $20 billion from state and federal. What we have done is create a data set that has every utility incentive in North America, as well as software that allows you to access it. So our technology simplifies the process of accessing these incentives, making it easy and accessible. And we make money because people pay for our software, and we also get a percentage of the rebate. What do? Our Utility Genius software provides simple access to a complex process. We have comprehensive information on all the incentives and rebates available. And we recently introduced our storefront product, which can be private labeled, whereby you can go onto our Utility Genius website, map out your project, your retrofit, whatever it is you're doing with your building, then go onto our storefront and purchase the products net of the rebate. And then we take care of the rebate for you. Our software is a SaaS product where we get subscription fees every month, so it's very reliable revenue. And we provide actionable data for our customers. Intelligence for all, again, allowing 20,000 plus visitors to our site every month to access this data and to action the rebates. Our storefront allows people to purchase products net of the rebate. We had a client in Long Island who was retrofitting a school. They were able to get $1,600 lights for $44 each. That's a significant rebate and difference. We work with some of the leading lighting, HVAC, and other manufacturers. We have 14 staff members, including our software engineers and data analytics folks. All of this was built from the ground up by Incentive. We have revenue. We are very close to profitability, but we expect that to accelerate. And we are raising money, $2 million, in order to enhance our sales and marketing, and also to implement, we have a white paper on how we can use AI to mine the data that we have to create better incentive programs and hopefully also identify where the best products are and provide that information back to our manufacturers. So that's Incentive Energy, and I hope to talk to you all after the showcase. Any questions?
I'm sorry, I missed it. Are you selling direct to consumers, to utilities, to companies?
So we are currently in the commercial and industrial space. So we work with utilities to mine their data if they are looking for additional rebate money. And then we also work with commercial customers and contractors and distributors to help them select the right products for their build or their retrofit.
And how do they find you?
That's part of our issue, and that's one of the reasons why we're raising the money is for additional sales and marketing. We've been in business since 2016, so we have a pretty good footprint within the lighting manufacturing space and the HVAC space. We've got great web presence. We try to get to as many utility and other conferences as possible, but that's one of our challenges, is to get out there and have more boots on the ground and try to get the product out there. And that's one of the reasons why we're raising this money.
Great. Thank you very much.
Thank you.
Hi everyone, my name is Tina and I'm co-founder of JP Robotics. We work on intelligent pipe surveying using robotics and AI. So the 1.8 million miles of natural gas pipes in the US are dangerously outdated with with like a few hundreds significant gas leaks and explosions each year, causing injuries, fatalities, and over 6 billion of annual damages and penalties. The core problem is that maintenance is reactive, and pipe inspection uses tools that are outdated, laborious, and lack insights. What's more, over 90% of the natural gas pipe in the US are under 8 inches in diameter, and these pipes are inaccessible and thus unmonitored by the current bulky technologies. This forces asset owners to rely on guesswork. Introducing our groundbreaking technology that combines advanced hardware with intelligent software. Our robot is able to navigate pipes as small as 2 inches in diameter, and it uses patent-pending multi-sensor fusion technology to create 7mm grade 3D digital twins of the pipe interior while accurately locating itself in GPS-denied pipes. Our advanced data power AI-driven analytics and diagnostics for deformation, corrosion, and more, generating actionable reports and maintenance recommendations. This technology is backed by ARPA-E, and we validated that our solution brings around values across the value chain, with 2 most important ones being efficiency and cost savings. So conventionally, inspection, mapping, and diagnostics are done by 3 separate service teams, and we are consolidating them into one single superior pass. This helps field inspectors to cut operation times by a factor of 5 while improving safety. For pipe owners, they see up to 70% cost reduction while seeing a transition into proactive maintenance. For engineering firms, they can use our 10 times finer resolution data to make more informed and smarter decisions. The key to our go-to-market strategy is to partner with major inspection service providers and engineering firms to leverage their existing relationship and contracts with downstream pipe owners to quickly penetrate the market. Our hybrid business model contains 2 parts. One is we lease our robot kit to inspection service providers, and we also sell our data-derived products and analytics. We're facing an $84 million per year natural gas distribution pipe inspection market. And if we also consider the maintenance, it will be $2.8 billion per year. And if we also take into account other sectors like storm, electrical, and petrochemical where our technology can be applied, our total addressable market would be $37 billion with 8% annual growth rate. Our founding team brings together expertise across sectors, including entrepreneurship, research engineering, oil and gas leadership, and fundraising. Over the past 4 years developing IP at CMU, we have secured $1.7 million initial funding from ARPA-E, developed deployment-ready prototypes, and completed 3 successful field deployments with industry partners. Now we have 1 full-year project and 2 paid pilots lined up. So we're raising $750K pre-seed round to turn our working prototype into a hardened MVP and get ready for our paid pilots. Thank you.
So sometimes with inspection technologies, it can be challenging to get the customer to pay for an ongoing inspection rather than looking for a problem that they know exists. Meaning, okay, I see a problem, I need to go out and understand the problem. And so do you require a regulatory driver or other requirement in order to drive your recurring revenues to do the inspection?
Yes, so regulatory incentives is important. So for natural gas, like Department of Transportation, they have regulations that ask pipe owners to inspect their pipes every once in a year or once in 5 years. So that is one incentive. And what's more important is because the pipe owners, they're seeing the pipes failing, and they themselves have industry best practices. They have own incentives to do this type of inspections.
How do you think about pricing your services to capture that value that you're creating?
So our pricing model has different tiers. Our basic tier contains like just the inspection and some standard reporting. It's kind of on par with what our competitors in other industries would charge. And we have additional tiers with advanced data capturing and analytics. So these are, so we did like customer interviews and testing to see if these price makes sense.
So when you say robotics as a service and data as a service, is it a monthly fee? Is it a per use fee? How are you, is it when I see a problem in the pipes?
So currently we're using like a distance-based model. So like the longer you inspect, the longer in terms of distance you inspect, like the higher we charge. Yeah, but depending on some of the asset owners, they might prefer like a year, like an annual fee or something, or like a per project fee. So it's we're open to varying our pricing model based on that.
Great, thank you very much.
Next, we have HQuest.
Okay. Hi, I'm George Skopsov. I'm the CEO and founder of HQuest. At HQuest, we have developed the most direct and straightforward path to decarbonizing industrial heat. We will install our compact, portable systems at our customer sites as close as possible to their furnaces and boilers. Each unit, every day, will pull out 3 tons of solid carbon from 200 MMBTU of natural gas before it can be combusted. 3 tons of solid carbon, that means 11 tons of CO2 per day per system that will never be emitted. Instead, our systems each system will produce a ton of clean, sustainable hydrogen, which can be blended for immediate emissions reduction. So hydrogen was supposed to be the solution to decarbonizing industrial heat. Unfortunately, it was a big disappointment. And the reason it was is because conventional hydrogen is dirty, has a huge CO2 footprint. The way it's made, so-called green hydrogen is very expensive to make. And whatever hydrogen you make, it's even more expensive to actually deliver it to the end user. So we're changing the status quo. We address every single one of those problems. Our hydrogen is clean and sustainable, and our compact systems will generate it at the point of use, basically eliminating the costs and risks of hydrogen transportation. So in essence, what you have is a clean, affordable, and most importantly, effective decarbonization solution. The reason it's clean and affordable is thanks to our carbon material. It's actually a product that people use, they want, and really, really need. The carbon material is carbon black. It's the oldest nanomaterial known to man. It makes tires stronger. It makes batteries, well, basically work. It's a $30 billion market that's growing, because people drive more, they use batteries, they use their cell phones more. But unfortunately, it has a very large CO2 footprint. Our carbons are identical in every way except for one thing. They are truly sustainable. They don't have that CO2 footprint. Otherwise, they are drop-in replacements, proven drop-in replacements for the highest grade carbon blacks out there. What makes it all possible is our transformational technology, microwave plasma pyrolysis. Basically, we use an intense microwave field to heat the natural gas virtually instantaneously to thousands of degrees. And at those temperatures, the hydrocarbon molecules literally fuse together to form carbon nanoparticles and release hydrogen. There is no oxygen, no oxidation, and therefore no CO2 emissions from the process. The technology is piloted with our strategic partner and investor, Peoples Gas. Peoples Gas has tested their pipelines with our hydrogen blends, and right now is doing tests on home appliances, stoves, furnaces, even a standby generator. It all runs right now on a 20% hydrogen blend. We have been developing our technology and applications since 2014. We have a very strong IP position with more than 14 granted patents. We have been supported by Department of Energy and the National Science Foundation, and we have significant commercial traction. Beyond carbon black, we can address many other sectors and industry verticals. But with carbon black, we have a very direct path to $2 billion in revenue over the next 7 to 10 years. Right now, all we need to do is execute. Thank you.
Could you speak a little bit to the scale of your pyrolysis process and what rates and volumes you're able to handle? Because obviously a lot of industrial heat has large use cases. So.
Right, absolutely. So when we're not looking at large scale industrial heat like cement, steel, we're looking at 190,000 manufacturing plants in the United States that use natural gas as their primary energy source, but they're relatively small and distributed consumers. You know, something like 50 MMBTU boilers. That's what we're targeting. And our systems, you know, it's basically a container that will generate a ton of hydrogen per day, 200 MCF of natural gas. It will have electricity consumption, but it will be 4 times less than electrolysis.
And just, again, as you noted, the thing that's held back a lot of hydrogen is the price per kilogram. Exactly. And the idea that the carbon black will subsidize or overcome the additional processing steps that you have. I'm just curious about how it pencils out. Yeah,
absolutely. I mean, so for every kilogram of hydrogen, we make 3 kilograms of carbon, and that carbon, basically, the very competitive price is $1.50 per kilogram. Right? And our inputs are natural gas and electricity. And in most cases, with our business model, we actually don't have to even pay for natural gas because it's the fuel that we're decarbonizing. And in many cases, electricity is subsidized as well.
And just to follow up on that, do you believe that the carbon black market is sufficient in size to support your scaling plans?
Yes, absolutely. It's a $30 billion market. We are not targeting to make every hydrogen molecule that will ever be needed, right? We are focused on decarbonization of those distributed small-scale consumers of natural gas. Carbon black market is more than sufficient to support it.
Thank you very much.
Thank you.
Next, we have RoboLoop.
Good afternoon. My name is Ned Eldridge, and I'm the CEO of eLoop LLC, and also the founder and majority shareholder. eLoop is in the environmental services business. We are in a collection of electronic equipment at end of life, and there's really two sides of that type of business. One, we recycle electronics that are beyond reuse, and then the other side of our business is we refurbish and resell a lot of assets in a secondary market. So for the last 17 years, we've been involved in trying to capture the right activity in this market and be able to differentiate ourselves with providing a level of service. Okay, one of the areas that we find to be really exhausting right now is the processing of flat panel televisions. If you look at how many flat panel televisions are out there in the market, imagine your household, imagine your population in your general area, and then add about 10 to 20%. Because everybody has TVs, they've got laptops, they got tablets, they got phones. Okay, all this equipment ends up at an end-of-life stage, and most of it does not get processed through an electronic recycler, and it ends up in landfills. So what we're trying to do is divert that material and recycle it all. As you can see, we have a big issue with the tech advancement because most people are still turned on by the greatest TV to watch the best game and have the greatest HD experience. So a lot of these TVs never make it to end of life. They just don't, they're no longer being used. And they have a shelf life of about 5 to 7 years. So after that, these TVs start rolling in. So if you look at the market we're trying to serve in State College, Pennsylvania, okay, we're going to have a market that's going to allow us to basically capture 21% of the nation's population, and through a group of about 50 recyclers that we've been in touch with, we're looking to bring their equipment to State College. So the key things that we're trying to do is get involved with disassembly. Right now, it might take a manual process of running screw guns, different types of tools to break this stuff apart. But through the ingenuity of Matt Travers and his team at Carnegie Mellon, we've come up with a way to actually destroy the fasteners and break those things apart. Now, the nice thing about the robots we're developing is they work all the time. So as we pace our volume, right now we're processing about 400,000 pounds a month in our State College facility. As we bring in our next wave of robots, we expect to get up to close to 1 million pounds a month. Even at that level, we're only going to satisfy less than 5% of the market share in that general area. If you take a 300-mile radius from State College, you cover all of New York, New Jersey, Delaware, Maryland, all the way through West Virginia, back through Ohio, and you've got a rather major population base. So our benefits are we're going to be able to have a number of valuable materials. Traditionally, out of a TV, you're going to get steel, you're going to get aluminum, you're going to get circuit boards, and you're going to get plastics. Right now, we're studying plastics to make sure that we have a good downstream for all of the engineered plastics, and we're working diligently to make sure we have good buyers for that product. The other area we're getting into, which is the biorecovery. If you can imagine when you look at that TV and you see that black screen, as soon as you disassemble it, it's a glass sandwich. Inside that glass sandwich is a paste. The paste in an LCD TV is going to be indium tin oxide. The paste inside an LED TV is indium gallium nitride. And through a second partner of ours, we're in the process of being able to scrape that material and create a pure indium and a pure gallium. Now, these are only our first two puzzles because we're working on flat panel TVs. But as we get into other electronics and build other robotic equipment that's going to serve that industry, we believe we're going to get into more rare earth recovery and things like that. The benefit we have in the market today is that we're the low-cost provider. If you look at the team, you can see we've got talent. Matt Travers, my partner, is here today. Scott Thayer, and then you've got the manager in State College, Vic Patel, and also Mike Ritchie.
So is your operating plan to be a vertically integrated e-waste recycler and then seller of distributed parts, or do you plan to sell your robots to already existing e-waste facilities?
We have an opportunity to try to see if we can scale the business. Right now, there's major consolidation going on in the whole electronic recycling industry. There's a lot of money coming into the industry and consolidating different ITAD partners. ITAD partners are the ones in reuse. And there are also some entities that are interested in the recycling side. So right now, we see an option to go in either direction. We believe we're going to be able to build equipment and sell equipment to other recyclers around the United States, but also build out our own platform so we can cover more than just flat panel TVs.
How do you manage the complexity of training your robots on a wide variety of different types of panels?
I think what we have found so far is that when we're dealing with fasteners, it's one of those situations where we're able to collect data about the make and model of the TV, and it identifies where all those outer screws are on the back panel, and it goes through, and we're not unscrewing them, we're punching them out. So we get speed out of the destruction. There's virtually nothing wrong with breaking the parts because they're going to get recycled anyway. When it comes to the steps downstream from there where you've got to sort and handle the materials, we do that at an electronic recycling center level anyway. But we believe we've got two avenues to go there. Thank you. Okay. There we go.
Next, we have Singularity Polymers.
Plastics. It's a dirty word, and I will start with the word plastic. But that being said, plastics is what makes the food non-perishable. It keeps our medicines the way we want it. It keeps our clothing. It's a lot of things we rely on because of the plastics. What we are doing here is basically getting rid of the multi-layer film structure out of packaging. So right now, how do we keep our foods and our medicine safe? We basically use a multi-layer film structure where you have polyethylene film, then you have an adhesive, then you have polyvinyl alcohol layer, and then again an adhesive, and again polyethylene. What we are able to do is get the same properties in a single layer material. And this makes it into a massive market opportunity, which is, in terms of polymer packaging, it's a $400 billion, but we are only looking at the flexible packaging, which ends up being $20 billion market. So that's where we are right now kind of focusing on. It gets me, I'm trying to keep my excitement low, so I think, or I will start really, really talking fast. I was taking a course and they were saying, hey, you need to bring your voice up, and I'm not doing that. All right, so. Okay, so which brings that, okay, why do we make it into multi-layer films? Basically, you got your PVOH, which are great at stopping oxygen, and you got your polyethylene, polypropylenes, great at stopping water. So if you want to package all those things, you slap both of them together and you have your multi-layer films, right? And that makes it multi-layer, expensive, non-recyclable material. It's basically all the dirty things we hear about plastics is one of this reason we cannot recycle it. So what we are doing is, I have my favorite ramen noodle over here. If you take that and you kind of pull it apart, you're going to see 3 layers coming out of a normal ramen noodle. What we are able to do is we are able to exfoliate clays through an ionic liquid technology, which allows us to really, really put clay layers onto the surface of these materials. And it makes it non-toxic, it remains transparent, and we can basically use standard processing technologies such as blow filming. We did a pilot at RIT. I actually have the film. If somebody wants to see the films and compare it with the normal plastics, you can see them. So this is the data I'm showing from the oxygen transmission rates. It's getting too technical, but I will just say we do really, really well when it comes to the OTR. All right, so competitive advantage. I think with nowadays, everything has to come down to cost. And I'm just going to go to one point that we basically reduce cost by 50%. And forget about its recyclability, forget about everything else. I think the cost could be itself a very major driver to put this product into the market. Our plan is going to be in a 4-level stages. We are right now in the customer engagement and scale-up space, then going into commercial pilot testing, early commercialization, and move on from there. And I think the sustainability as well as the recycling demand is going to make it really move forward. So currently we are planning to raise $20 million in 3 stages. It's going to be 3, 5, and then 12. And we can talk about the details in terms of what are the milestones. With that, I want to introduce myself and my business partner, Carlos, who is also here in the audience. And we have a lot of equipment which we are leveraging to get this technology into the market. And I'm open to questions.
Can you speak to the scale of your manufacturing and what you've been able to demonstrate? Because it's a big problem.
Yeah, I mean, so right now, all the work we have done is in kilogram scales. We have been able to make our master batch in multi-kilogram scales, but our scale-up is going to be in massive quantities. So that's why we have to raise that amount of money.
So was that kilograms of your material that you're then using to coat the polyethylene?
Sorry?
Was that kilograms of the material? I'm talking about also the finished plastic and the rate that you're able to produce it at, right?
So the master batch we are producing is around like 28% loading. And our loadings end up being like 0.1% in the final product. So that few kilograms we can make basically translate into hundreds of kilograms of the final film.
And on that journey, what technical risks remain? I would imagine it's non-trivial to distribute homogeneously the clay material.
Yeah, so there are tons of technical risks, okay? There are sealability issues. We have to address those, but I think if we have to think from that point, we will have to look into different types of polyethylene grades, blends, which we have not done. We also need to really optimize the right amount of loadings, which we have to go through. But I think the key resistance is going to from the customers because they have been so used to using multi-layer films. I think convincing them that this is going to save you money and it's going to be recyclable, I think that's going to take some effort and marketing. All right, thank you.
Next, we have Farm to Flame Energy. Just a gentle reminder, if you haven't already started, please start signing up for the one-on-one meetings if you are an investor in the room. Thank you.
Hello, hello. Let me see something real quick. Okay, all right. How are you doing today? Good, good, good. My name's KJ. I'm CEO and co-founder of Farm to Flame Energy. And we make smokeless, odorless, renewable power at half the cost of diesel. We're tackling the $4.4 trillion global power market and specifically disrupting the $23 billion diesel generator market. Our serviceable attainable market goal is $3.4 billion in annual recurring revenue by 2032, with 4 million kilowatts installed, or enough power to light up half of New York City. In most of the US, getting electricity is as easy as turning on a switch. But 700 million people around the world do not have access to affordable and reliable clean electricity. This population relies on expensive and dirty diesel generators for constant power. It costs 3 to 4 times the regular electricity price on the grid to operate diesel generators. Toxic diesel exhaust kills over 21,000 people per year. And if for some reason they can't get their hands on diesel fuel, well, they have no power. We've built the Farm to Flame generator, a carbon-neutral electricity asset that is just as reliable as diesel, but half the cost, with no smoke and no odor. We utilize feedstocks like corn stalks, wood waste, miscanthus, and paper waste for carbon-neutral electricity generation. And one of our 30-kilowatt generators could power 3 homes, a commercial building, or a medium-sized farm. Our patented smokeless and odorless combustion process has allowed us to achieve a blue flame, equating to high combustion purity, less maintenance than traditional wood chip generators, and increased revenue. Here's a real picture of the blue flame we achieved, and here's a picture of the FTF 30-kilowatt generator that we built in 2021 with funding from the US Environmental Protection Agency. And we're cheaper than existing options. We're cheaper than diesel by half. We're cheaper than solar plus storage by 2/3, as the battery paired with the panels prohibits cost-effective baseload power. And we're cheaper than anaerobic digestion by half. Farm-to-flame generators operate at 14 cents per kilowatt hour with no methane, no conflict minerals, and no toxic emissions in our carbon-neutral supply chain. We have $5.28 million in the pipeline for 2025 to 2027. We are signed into a $20.4 million engineering, procurement, and construction agreement, plus a 3-year operation and maintenance contract with Cocoa Processing Company, a large chocolate producer for Golden Tree, in which we're converting their cocoa husk into combined heat and power. And we are signed into a service agreement with Georgia Pacific, the largest wood waste electricity producer in the country, in which we're providing a $1.7 million annual recurring revenue replacement of their natural gas paper dryers with farm-to-flame dryers. We have a world-class team of co-founders and executives who have built the Farm-to-Flame generator and have been funded by world-class organizations including Cisco, the US EPA, Bank of New York Mellon, and Georgia Pacific for over $2 million in non-dilutive funding. And we have a great team of advisors who successfully raised and exited over $515 million in their previous companies, selling to BMW, General Electric, IPO, and recently Michelin. The $5 million raise enables Farm to Flame Energy to install 1,000 kilowatts of Farm to Flame generators on the East Coast, creating an additional $1.1 million in annual recurring revenue to the $24.9 million in contracts that we have. We will commence installment of over 50 megawatts, 50 mil ARR, of Farm to Flame generators, and we will hire a world-class team of power generation specialists to help us get there. Over the next 24 months, we will abate over 396,000 tons of carbon dioxide from diesel and natural gas. Join us as we scale to 4 gigawatts with over $3.4 billion per year in revenue and $12 billion in carbon-neutral electricity assets as we expand energy security globally. Thank you so much. My name is KJ, CEO and co-founder of Farm to Flame Energy.
Hey, KJ.
Hey, Jeff.
Tell us a little bit more about your use of the funds in this upcoming raise and maybe some of the relationships that you would like to continue to build.
Yeah, so a lot of it is about business development. So we procured 5.3 megawatts with $1 million in dilutive funding, and now we're about to go execute on those. And so we are going to procure an additional 5 megawatts with this raise. If we were to raise 10, we would procure an additional 10 megawatts. And these projects are basically centered around a Linden Furniture contract, our Georgia Pacific work, the Cocoa Processing Company contract. We just started some work with Duquesne Light. And it's really all EPCs and PPAs, which is one is engineering, procurement, and construction. That's what the corporate prefers. And the PPA is where we own the generator and sell the power. And that's what certain industries like sawmills would prefer. So a lot, is into business development and project development.
So can you talk to me a little bit about your primary customers? And it sounds like, are they mostly food and like food and wood waste processors looking for cogeneration?
Yeah, that's exactly correct. Like, I just went to the biomass conference in Atlanta last week, and it was a lot of forestry-based companies, paper and pulp. In fact, I'm going to a paper mill in Tyrone next week to visit their facility and do the same work we did for Georgia Pacific. That's a lot of agri-industrial, food sludge, seafood sludge, pork sludge. All of these are liabilities that cost a certain mill. It costs them like $600,000 a year just to dispose of their waste. So it's not just an energy problem, it's also a waste management problem, to your point. All right.
Next, we have Sensible Photonics.
Okay, thank you very much for the opportunity to be here. I'm Paulo Hodnicki. I'm co-founder and technical lead at Sensible Photonics, and I'm here today to talk to you about how we are seeking to eliminate predictable distribution asset failures. The US economy incurs more than $150 billion in economic costs associated with power outages annually. Despite the fact that we would like to see the frequency and intensity of power outages decrease, we're actually seeing the opposite. Over the past 5 years, we've seen an increase of 60% in blackouts. Within the transmission and distribution system, we have reasonable levels of visibility from the generation, transmission, substation, even down to the residential level using existing sensing instrumentation. But we have a complete lack of visibility within the distribution system. The reason for this is that we have a number of technical challenges associated with integrating sensors and medium voltage assets such as distribution transformers, but they're widely distributed and they're not as expensive as the larger transformers which are typically monitored. Despite the fact that 90% of these failures which we're seeing actually occur in this last mile of service known as the distribution system. At Sensible Photonics, we're seeking to change that paradigm, bringing low-cost, high-capability fiber optic-based sensing solution to the distribution grid, monitoring assets such as distribution transformers, and bringing new levels of visibility to the utilities. Our technology involves low-cost fiber optic-based sensing, enabled by a number of proprietary material and device innovations that have been patented, which enables us to use source and detection systems which are an order of magnitude lower cost than traditional fiber optic-based sensing. So we leverage the advantages of fiber optics for medium voltage electrical systems, safety, isolation, ease of installation, but we are able to do it at a cost that can be widely deployed commercially. We have a number of key parameters that we're looking to measure internal to distribution transformers and other assets such as storage systems. We've been able to demonstrate integration and to demonstrate compatibility with existing wireless commercial sensing platforms that allow us to directly integrate with utility operation systems. In addition to the hardware, we're also looking to deploy asset-level analytics in our first round of products, which would provide real-time information about temperature, asset lifetime, incipient failures, as well as real-time risk indicators. As the product is deployed across the grid, we're integrating into the grid visibility platforms of existing analytics to provide new information about asset health into existing analytic frameworks. The company was initiated through more than $5 million of prior funding support through the Department of Energy, initially through the Grid Modernization Initiative. We have collaborative technology partnerships through licenses at University of Pittsburgh and NETL. We've won multiple R&D 100 awards. We've participated in the Alpha Lab Gear program and have a number of other funding support through Rocket Fund and SBIR grants. Our customers are OEMs and utilities. We're looking to integrate into existing transformers as retrofits with utilities, as well as new instrument into new transformers that are manufactured by developing a partnership model. The model for these transformers and their sensing is extremely large. We're estimating about $1 billion with conservative capture rates and both existing transformers and retrofits. And we're also looking at expansion markets such as electric vehicles and grid storage. We've got an extremely robust team of business leaders with international prior sensing instrumentation experience, as well as technology and technical co-founders, including the inventors of the core technology. We also have ongoing partnerships with a number of partners at University of Pittsburgh, Duquesne Light, Eaton Innovation Works, and Connected Energy. We're currently completing our pre-seed round utilizing SBIR funds and other grants to take our technology to the next level. With our existing partnerships with OEMs and utilities, we're moving into the pilot production and testing, and that's where we're initiating a seed fundraise here over 2025. After we are able to secure existing commercial orders at scale, we'll be moving to scale our technology, and we're looking for partners in terms of both investment and pilots that we would be able to partner with in taking Sensible Photonics to the next level. Thank you very much for the opportunity.
What's the feedback you've heard from utilities to date, and what do they need to see to integrate your solution into the network?
Yeah, there's a lot that's changed over the last 5 or 6 years. So if you would have asked me that question 8 years ago, the typical failure mode was a run to failure, and then they would go replace the transformer, turn the lights back on. Recently, we've had a lot of interest, and this is being driven by supply chain constraints for transformers. They used to be a commodity item. Now they take 1 to 3 years to be able to procure new transformers. We're also just seeing increased demand in general. So we have a lot of interest of being able to provide visibility. We're also finding utilities are actually taking down transformers, refurbishing them, and then redeploying them, which is a new development, which actually provides us with a really clear pathway to retrofitting. And so we've seen a lot of interest from the utility side.
No, I'm just wondering if you thought about commercializing some of that data.
For sure, yeah. And so initially at the first level of products, we're looking at asset level so that utilities have direct indicators of lifetime risk, incipient failure. But as you have more and more of these deployed across, we're looking at, for example, integrating with demand response platforms. So instead of just keeping the price of electricity low, you can also extend the life of transformers and other types of distribution assets. So that's definitely, as we scale, we really see the ability to capture that revenue stream being extremely lucrative in the future.
And what does the scope of your first pilot look like?
Sure, we're currently working with a major manufacturer integrating our sensors into their commercial transformers. We actually are looking at 2 manufacturers that we're working with. We're leveraging facilities at the Energy Innovation Center downtown where they have medium voltage testing capabilities. And then the next phase will be to actually deploy those transformers on the grid and to demonstrate wireless communication with them in operation.
You already have a utility partner.
Correct, we're working with Duquesne Light on one of our SBIR programs. And we have other utilities, rural co-ops, and others that we're talking to as well. Thank you very much.
Next up, we have Optimus Technologies.
Awesome. My name's Colin Heiler. I'm the CEO of Optimus Technologies. At Optimus, we design and manufacture fuel system technology to decarbonize heavy-duty diesel engines. Over 70% of the US freight moves by truck to its destination. These trucks represent only a small fraction of the vehicles on the road, but they contribute over 25% of the transportation greenhouse gas emissions because they're consuming over 40 billion gallons of diesel fuel annually. Trucking is hard. These fleets generally operate at about a 3% margin. It's a commodity business. At the same time, shippers are increasingly putting pressure on these companies to reduce their carbon emissions to meet interim and long-term net zero targets. But they're not asking trucking fleets to go in it alone. They're willing to help cover the cost of that sustainable transportation. They can cover an incremental cost because, again, this is a commodity business. They can't fundamentally accept order of magnitude cost increases, which is what you see with electrification or hydrogen technology in this Class 8 space. Ryder, one of the largest global fleets, did a data study on their existing assets and determined it would take every 1 diesel engine would take 2 electric Class 8 trucks to replace it. That at a cost that's 2 to 4 times what existing diesel vehicles are, and with about $1 trillion of infrastructure upgrades. That's where we come in. Our technology upgrades existing diesel engines to operate on 100% biodiesel. Today's engines are limited with low biodiesel blends up to about a 20% maximum. We remove that blend limitation while never inhibiting the engine from operating on traditional diesel. And although the Class 8 market's our first entry, The technology is applicable for anything with a diesel engine, boats, trains, agricultural equipment, so the market opportunities are endless. So why 100% biodiesel? Well, biodiesel, frankly, is the lowest cost, lowest carbon option for decarbonizing these large engines. Biodiesel can achieve over a 90% Scope 1 carbon emission reduction. Our technology costs about $25,000 per engine installed. We capture a recurring subscription that gives fleets access to analytics and carbon reporting. We can upgrade existing trucks that are already in the fleet's operation, or we've established partnerships to ensure every major truck manufacturer can integrate our technology in new trucks as they get built. And that's why today we have over 1,100 units in operation that have accumulated over 100 million miles. Some of the largest fleets in North America are relying on our technology to meet their decarbonization targets. Last year, we did about 10 million in revenue, up from about 5 million the year before. We have really good gross margins, over 50%, even in small volume manufacturing that we're doing today. So we've got a lot of opportunity to enhance that. And we've built the necessary structure and partnerships to ensure scalability, from fuel producers to truck manufacturers, installation partners, and infrastructure partners. This hasn't happened overnight, though. I've been working on this company for the past 15 years, and we've recruited deep industry experience with a team of about 50 here in Pittsburgh, and we're committed to doing our manufacturing here. We're working now this year to go out to market to raise our Series B to continue to scale our impact. Appreciate the opportunity.
Do you have data on your engine runtime and durability?
We do, yeah, and we've done, we did a 1.3 million mile study specifically with the fleet, comparing our assets to diesel assets. But in addition, our analytics, we get, our commercial launch of the product was in the field in 2018. We have data from every single engine that we've deployed every 2 seconds since it's been in operation. So we have a massive data set for durability and operations.
Does the supply of B100, including its geography, support your business scale-up plans, and how are you managing that?
It does, and in fact, so Pilot Flying J, just last week, we announced a partnership with them. Travel centers today have 100% biodiesel on site. They actually blend it today, so they're blending it into the diesel stream. So the fuel's available. It is decentralized across the country. We also have partnerships with the leading biodiesel manufacturers. So fuel production at some point is certainly certainly taken into consideration for the model, but accessibility and availability is not a challenge. And pricing today, Pilot's pricing the biodiesel on parity with diesel.
Just what's the extra revenue that people are able to generate once they make the switch? Because it's a cost unless they can charge more.
Yeah, so there are regions where there's actually economic incentive where it is a cost savings, but generally speaking, a shipper is willing to pay somewhere between 5% and 7% more. If you look at the total cost enhancement from a fleet, it allows them to capture up to a 9 or 10% increase in their margins. Awesome. Thank you.
Next up, we have Frontline.
Good afternoon, everyone. I'm Dr. Kyla Fleming, founder and CEO of Frontline Gig. We are a predictive hiring platform for the future of trades. The secret sauce that we bring is that we use AI to curate hyperlocal talent pools of entry-level and blue-collar talent, equipping them with the cheat code to scale faster and to win. So we're in a world today where the average young person, when they dream of what they want to do for the future, they're more likely to have an ambition to be a YouTube star than to be a carpenter or an electrician or even a robot operator. This puts our cities at risk because we won't have the technicians that we need to work on getting critical infrastructure installed, and of course for businesses that are looking to diversify and add robots, who's going to help them do that? So where do we put the blame? I have to point out then our workforce system. It's siloed, and in general, the workforce system that we have is struggling to keep up. As evidence of that, the Department of Labor reported that 70% on average of the individuals who sign up for year-long apprenticeships end up dropping out. So this is why we have Frontline Gig. We work as an extension service to the workforce system, bridging the gaps that are needed to get more individuals future-focused in building the skills of the future, whether we're talking about clean energy, green infrastructure, or even things like manufacturing of the future. Central to how the platform operates is the career coach that we have. It's looking at an individual's skills, experiences, and potential, reducing it to a score, and using that to help guide what they do next so that they can get the jobs that align with their aspirations. This career coach is being deployed here in Pittsburgh, and in the near term, at least 1,000 individuals will have a shot at being supported by the career coach, and to the extent that there are gaps, several hundred will get a shot to build hands-on experiences. We're able to seed these experiences because of our partnership with, we have a $1 million partnership with Dream.org, GitLab, and American Forests. And so what this also demonstrates is that there's a thirst in the market for deploying more integrated career services that are getting our young people the exposure and the experiences that they need to be ready for the future, building high-paced careers that pay more than $50K. So we're selling into a $100 billion market. One of the things about, because of the approach that we are using to support talent, we end up collecting so many more data points so that in addition to having the individual be better supported, once we now think about employers, we are getting them better matches. So we make money via services and subscription fees for preparing and placing talent. We are raising $1 million, and that will accelerate our AI build-out and also our go-to-market. We have line of sight to the first $250K. We're still looking for a lead investor, and I'd love to continue the conversation, whether it's for investment or for how we can work together here in Pittsburgh to get more individuals skilled up for the future. Thank you so much, and happy to take any questions now.
How do you find your workforce?
You get that question a lot. So in general, there are so many young people who are looking for a shot and an opportunity to get connected. So we partner with organizations who already are trying to do something with a workforce. So this can look like literally existing workforce programs, or it can look like non-governmental organizations that are looking to support an individual, and workforce becomes an add-on service that they can provide. Separate from those places where they're already attached to an organization, we also find them in the wild, meaning you can advertise on social media for different services that you want to be able to provide, and people respond to that as well.
How are you subsidizing the learning path for the employees? You come in and you say, hey, in order for you to be a nuclear technician, you got to do these 3 things. How do you pay for that? How does a person pay for that?
How does the employer fund the pathways?
Or self-funded as well?
So the initial offer for the employer is that, so we are doing some of the skilling outside of the employer. So the idea initially is that because we have, partnered with workforce programs and other things to prepare the individual, by the time that we are coming to the employer, we're focusing on entry-level talent initially and maybe a little bit of mid-skills, but you're now coming prepared. So we initially are looking to be faster than Indeed at matching talent and cheaper than a recruiter for our initial prop. Longer term, in terms of internal programs that employers might want to run, one of the specialties is being able to offer short-term, flexible, rotation-based programs, and that value prop is for both workforce programs and for employers. And so to the extent that they want us to support that, then that becomes something that you mark up 30% essentially. So, the individuals get paid as they're learning, and then, there's a service fee on top of that.
Next, we have Lean FM Technologies.
So we have developed an intelligent fault detection and diagnostic software for commercial heating and cooling systems. And the cool thing about our software is it can work with any building automation system. And it uses machine learning to, rather than a rules-based system, to gather data from thousands of data points and can find issues and inefficiencies in a building that our competitors can't. And so what we ended up finding was that we can find 30% savings in a customer site's HVAC system. And the problem is big, $50 billion a year in energy waste in buildings, 40% of that in HVAC usage. And there are two main problems here, is that facilities managers are overwhelmed with the amount of data they have to sort through, and the field teams are just running from ticket to ticket and can't get ahead of it. And so we're trying to help them with that. We work best with buildings like this, large 100,000 square foot or more buildings with smaller spaces. They have tons of sensors and tons of components. We are currently working with Carnegie Mellon, Penn State. We are just now rolling out a project to expand to 26 buildings on the main campus of Penn State. In the coming weeks, we're rolling out to Raymond James, Cook Children's, and a hospital in China. There's a lot going on here, but in the middle, the digital twin. This can take, with other systems, weeks to match the component on site with the digital twin in the software. Our AI can do this in a matter of hours. And then when you get into the software, we can show our customers what the root cause of their issue is and how much energy they can save by repairing that issue. So, value proposition is huge, but the two main ones I want you to focus on are the energy savings, which we already talked about, 30%, right? If we can save a building 30% in their energy costs, it's gigantic. But if we run into an organization that is not energy savings focused, we can certainly help on the operations side, where we help them improve the reliability of their building automation system, but also chase down the root cause of some of the issues they may have been trying to tackle over months or even years. I'm Nick, I'm the CEO of the company, but the two smarter people on this slide are Burju, who is the current Dean of Civil Engineering here at CMU, and Pine, who's made it his life mission to make every building he comes across much more efficient. And where we are right now, we have 3.4 million square feet under pilot projects. I think we can expand to 10 million square feet within the next 2 years, bringing us about $1 million in annual recurring revenue. And how we're gonna do that? This year, We are coordinating with Penn State and CMU to develop an executive summary dashboard that will show them the priority actions, and they can dig into the software if they need to, but they can see the priority actions, the energy savings from taking actions, and external factors like weather. We also want to improve our AI algorithm. AI is exploding, and we want to take our software from a supervised AI to an autonomous AI. And the goal there being to plug it into existing automation systems so that we are just an option for them. They just flip a switch, and we are now in their system. And this is how different we are compared to the competitors that we go up against. It's an amazing software. I'm surprised. I'm new with the company, been here for 2 months, and I'm amazed at the results that we're seeing. So that's Lean FM. I'm Nick Boris, and open to questions.
Speak to me a little about your ability to integrate with different systems, right? Different buildings, different components. Are there limitations, or are you agnostic to the technology?
We're agnostic. If it's within 20 or 30 years old, even 30-year-old programs we're able to integrate into.
And then the 30% energy savings claim, where is the data backing that over? Where's that coming from?
That's on a much longer presentation, but we have slides where you can see where they'd make the change and it goes down from there.
Okay, so that's real world data then?
Correct, yes.
Where are you guys at in terms of current revenues, and how are you thinking about the growth rate for recurring revenues?
Last year we were just a hair under 200,000. This year I just closed about 200,000 in sales in the past 6 weeks. We're projecting a little over 300 for this year. Good? All right, thank you.
All right, we are at the halfway point. If we had a halftime show, it would be now, but we don't have one. So next we have Arieka.
All right, thanks so much. So my name is Karmal Majidi. I'm CTO and co-founder of Arieka. Let me just get back here. And at Arieka, we're introducing a new paradigm in thermal interface materials that addresses key bottlenecks in cooling and thermal management of semiconductors, primarily for computing and also power modules for electric vehicles. So probably don't have to convince a lot of you that AI and electrification are driving tremendous growth in demand for energy and energy consumption. But what a lot of you might not know is that 40% of this demand and energy consumption is just for cooling the semiconductor. And so that represents a tremendous challenge, but also opportunity. Now, one kind of example of this is, of course, a server rack in a data center. And this kind of shows you here, this video shows you this purple and orange material there. Those are what are called the thermal interface materials. And they're really kind of a key factor in the power efficiency of these computing systems. And so existing thermal interface materials, or we call them TIMs, are good enough to handle the power densities of existing processors and power modules. But when you look just in the next few years with this growing demand and also growing performance and enhancement in power density, these TIMs are not going to cut it. And what that means is that there's going to be greater burden on the cooling systems and hence even greater energy consumptions of these semiconductor-based devices. And so that's really where Arieka's breakthrough material comes in. What we're doing is taking two established technologies in thermal management. We're taking basically polymer-based TIMs, and we're literally blending it with liquid metal-based TIMs, and we're creating this new material system that exhibits kind of best of both world type properties. We're overcoming a lot of the limitations with thermal conductivity of polymer TIMs, but we're also addressing some of the key shortcomings of solid metals and liquid metals when it comes to mechanical reliability. We're raising a Series B, and a lot of this is going to build on a lot of the great commercial traction and progress that we've made in a couple of different market entry points. One of these areas where we've actually gotten our first design wins is in this domain of silicon carbide semiconductors for power modules that are used in electric vehicles. So here we've made really exciting progress and are currently ramping to production. We've also graduated from technical qualification now into business unit qualification and are currently working with procurement on getting our TIMs into smartphones, laptops, other consumer electronics, and this is with the leading global electronics manufacturer. And we've also had really good traction in technical qualification in the domain of AI-enabled computing. And this is with quite a number of different semiconductor manufacturers, integrated device manufacturers, OSATs, semiconductor fabs, and also fabless designers. In addition to all this great customer traction, we've also been really integral to the innovation and research ecosystem for the next generation of thermal management and cooling solutions in computing. And we've also established a very strong partnership with a manufacturing partner, Nissan Chemical. This is their Sudagora plant outside of Tokyo, where they currently have the capacity to manufacture 1 metric ton per year of our material, and we plan to scale that up as customer demand grows. I'll just quickly wrap up here with our team. Navid Kazem is the CEO and co-founder, and he leads this really passionate, exciting group of engineers, chemists, mechanical engineers, and also folks with strong business ties and background. We also have a really great set of board of directors, including former board director of Nissan Chemical, our manufacturing partner, and also the former CEO and president of Amcor, one of the large OSATs. All right, thank you.
Where in the value chain do you have to get designed in at the module level, at the chip level, and then how do you think about the timelines associated with getting your product designed into the value stream?
Yeah, we have to get buy-in at the module level. So a lot of the fabless designers basically request that the semiconductor fabs and the OSATs basically incorporate our material into their manufacturing process. The timeline for that takes a few years. We were founded in 2018. Now we achieved our first design wins and have concluded a technical qualification and are ramping up production. And so it takes, I wouldn't say it will take that long for the next set of customers. Now that we've gotten our beachhead customers, we anticipate it'll take about 1 to 2 years with subsequent customers to get designed into their next products.
And what do you think is the right market? Power with things like silicon carbide, GaN, or do you think that GPUs are the right market?
So in the near term, silicon carbide, that's certainly one market for us. But yeah, longer term, we do GPUs is an important target. CPUs, servers, data centers, that's going to be kind of the longer term direction. And that's an area where we're currently under technical qualification.
Can you share a little bit about your cost position and margins?
Yes. So I would say that the margins are comparable and the costs are comparable to other thermal interface materials out there. I mean, we are engaged in pricing negotiations right now with a large electronics manufacturer. I can't get into the details of it just because it's in process, but I would say it is comparable, despite the tremendous value that we add with the enhanced performance. All right, thanks.
Next up, we have sustainable composites.
Yep, other way. Good afternoon. I'm Don Morrison. I'm CEO of Sustainable Composites. We turn scrap leather into new leather. So what's the problem? The problem is large, it's growing, poses an existential threat to the survival of the planet. So of course, I'm talking about cows. Problem is, nature didn't make cows perfectly square. As a result, 50% of all leather produced in the world ends up discarded. That's nothing new. Think about that. 50% of all leather is thrown away or incinerated. What's new is our growing awareness of the environmental impact of incineration or landfilling, causing most corporations to take up sustainability pledges related to carbon or landfill avoidance. So what's the solution? The solution is Inspire Leather. Our patented technology takes industrial and post-consumer waste, recircles it into a new base material that can be repurposed and refinished and used in most of the same applications as traditional leather. Our process starts by taking scrap leather, grinding it in a very proprietary way. We add our proverbial secret sauce to create a base product that can be refinished. Our continuous process yields a material that's consistent in size and thickness, and the fact that we use third-party manufacturing makes our business model extremely capital efficient and highly scalable. The value proposition, why should someone care about what we're doing? For tanneries who might license our technology, we can save them over 30%, 33% in their cost of goods because our product is made on specialty paper machinery. For consumer brands, we can provide a minimum of 10% yield improvement. The environmental proposition we offer is 100% landfill avoidance for customers whose product we recycle, and our product in its own manufacturing process generates 75% less CO2. We provide material circularity to both customers. Part of our magic is in how we grind the leather scrap. The two slides on the left show a microscopic view of cell structure of a traditional leather and our leather material called Inspire Leather. You can see the cell structure is almost identical. Products on the right are pseudo-competitors that are using some unfinished scrap leather that are usually backed with plastic and then coated with plastic. So they're basically more single-use plastics. Ours is 63% leather fiber content, which means our material can be used in the same applications as traditional leather, particularly footwear, which is demanding of breathability. We process 3 distinct waste streams for our products. Our MVP came from Wilson football scrap leather we developed for Timberland. But the big opportunity in the market we see is in cutting room scrap. That's where we take customers' own scrap, process it, and sell it back to them. So our customers must eat their own dog food. So we're also working with several companies on post-consumer upcycling. We have a sales funnel right now of over 60 companies, most of whom have come to us asking for help with their leather scrap problems. So this shows the different stages of commercialization. We have a revenue model that's really two-pronged. We're going to receive most of our majority for revenue from licensing and royalties and direct product sales in the US and the EU market. The licensing, we believe, will come primarily from major tanneries in Asia. It's a huge and growing market, $6 billion. We have a smart team. We're raising $2.5 million in a priced round, $12.5 million pre-money. And why us, why now? We have proprietary scalable technology, compelling financial and environmental value proposition, extensive sales funnel, $6 billion market, experienced and balanced team, and a significant exit opportunity. Thanks for listening.
How big of a motivator is the avoidance of tipping fees for your customers?
I'm sorry, I didn't catch that.
How big of a motivator is the avoidance of tipping fees or landfilling fees for your customers?
Great question. I'm glad you asked that. There's a warehouse in Vietnam right now with 11 million pounds of Nike scrap leather. Think about that. Nike would rather pay to put that scrap in a warehouse than landfill it or incinerate it, which is what they would typically do. Why are they doing that? A couple of years ago, they took a sustainability pledge in their annual report to their shareholders that they were going to reduce their carbon footprint. The bad news for Nike is that their Air Jordan line is doing very, very well, and as a percent of their overall business. And the sneakerheads who are buying Air Jordans don't want synthetic basketball shoes. They want leather. So Nike became the world's largest consumer of leather, over 500 million square feet. So they've got a real problem. They have all this scrap leather, and they don't know what to do with it because it's going to really impact their carbon footprint. We have the solution.
Have you talked to Nike?
We are at the table with the two largest footwear tanneries in the world, both of whom are owned by even larger footwear manufacturing companies whose combined volume is $10 billion, 10 billion with a B, first cost footwear to the global footwear market. So, yes.
Can you just explain, if it's a proprietary manufacturing process, how do you use third-party manufacturers?
Great question. The two co-founders, who are the smart ones of our team, worked together for a decade in a division of Armstrong. It was a specialty paper division that made gaskets for the auto industry. Gaskets are made with a fibrous material. It's mostly plant-based pulp. And they started playing around with this leather idea. And the co-founders sold the business. They spun it off from Armstrong and grew the gasket business from 30 to 130 million. Sold it, and the acquiring company didn't have any interest in acquiring the leather technology. So they took their knowledge of specialty paper equipment, started sustainable composites, and took years to really figure out and perfect how to actually recycle a scrap leather. Thank you.
Next up, we have Sea Lion Energy.
Good afternoon, everyone. My name is Renuka Haider Khan, and I am the founder engineer of Sea Lion Energy. We spun out of CMU in December 2023, and we invented a material that extends battery life by 10x. So our coating technology, when applied at the battery interfaces, can reduce the risk of fires. It also extends the cycle life of not only the fresh batteries, but also the degenerated and used spent batteries by 10x. And so we use high energy dense materials that promote fast charging. And this enables us to contribute to the circular economy by developing a 1,000 kilowatt per kilogram lifetime with low carbon footprint. And so our key solution is called TARDIS. It's a coating technology that regenerates spent or used batteries and gives it second life, especially powerful special life applications, especially for the four-wheeler electric vehicle battery and the two-wheeler scooter batteries, and many applications in space and renewable grid. And so we adapted this process from the chip-making technology called the chemical vapor deposition, CVD. And this coating technology, when applied on the base material of the battery materials, it acts as a protective shield and prevents the batteries from cracking or other mechanical degradation. And so this process is completely scalable, right from the batch process to the roll-to-roll. And this makes it easier for the process integration into the manufacturing and the production lines. And so our process is patented. We specialize in precision engineering. Our coatings are completely customizable, and we also have an intelligent automation system where you can have the flexibility to choose from 70 plus chemistries. And for the design to synthesis, it just takes 1 week. We've already demonstrated this at lab scale. And we've seen a 17x increase in the cycle life. We demonstrated this to the Department of Energy, and they're funding us $2 million for the scale up. So with the 10x growth in the battery deployment, the coating markets are going to approach over $2 billion market annually in the next 4 years. And we are targeting to implement TARDIS to transform the batteries across various industries like electric vehicles, grid storage, and aerospace applications. So the business model for us to engage our customers right now is called the coating as a service model, wherein the battery manufacturers or the OEM manufacturers send us the raw materials. We coat their raw materials and send them back, and as a result, we charge them per unit basis. But once the scale-up is done, we are going to implement the infrastructure there back into the manufacturing lines or the production lines for the battery assembly system. So these are our competitors, Forge Nano and Volexion. Both of them are limited by 1 or 2 chemistries at the most, but we have a flexibility to choose from variations of polymer coatings. We also concentrate on the second life of batteries, which has a huge potential. And so this is our team. We spun out of the mechanical engineering department in the beginning of 2023, and Rija Jain is our founder and CEO. We have a diverse team of founding engineers and also a team for commercialization. We have forged partnerships with the inventor of the CVT technology and also with NRL for testing. We also do the techno-economic analysis with collaboration from CMU. And so the ask is, we are commercializing, and we need $3.4 million for the commercialization, where we will be using that money for hiring new process engineers, for taking up a pilot facility, and then for the go-to-market strategy. So if you're interested, please join us, and you can contact us. Thank you.
How does your coating technology integrate into existing cathode manufacturing once you've coated the particles?
So we have 2 types. So either the OEM manufacturers, which start from the powder stuff, and then the second one is once the powder is made into a cell. So we can provide the infrastructure and directly connect it into the manufacturing line. And it's completely chemistry agnostic, and it can be either cathode or anode. So it doesn't depend on the chemistry of the battery cells as well.
I noticed you're also hiring in India. How are you planning to target the Indian market?
Yes, so right now we're in talks with a big company which does batteries for 2-wheeler scooters. So yes, so we are targeting 2 offices both in the US and in India. Yeah.
And is the pilot facility equally agnostic when you are looking at how you might be able to work with various materials?
Yes, yes.
And is that located here? Or will the pilot facility likely be located?
Right now we are searching in Pittsburgh. So yeah, I think the first one will be in Pittsburgh. Yes.
The data that you've generated, coin cells, pouch cells, can you just talk to me a little bit more about the cell?
So for the lab testing, we usually implement coin cells. But for the scale-up, for the roll-to-roll processing and the batch processing, we will be doing the pouch cell processing, yes. And then later on, we will switch to the roll-to-roll, where we coat probably to scale, probably comparably to what the production industries are looking for.
Next, we have Superpowers Mobility.
We're developing proprietary electric off-road vehicles that are superior to anything on the market in terms of durability, off-road capability, and customer experience. Our electric off-road vehicles can operate indefinitely off-grid when charging from renewable energy. I'm John Powers, and I'm founder and CEO of Superpowers Mobility. I just returned to Pittsburgh, Pennsylvania after 4 years at Tesla, taking the Cybertruck from concept to production. And I think Pittsburgh is the perfect environment for a deep tech startup like Superpowers Mobility. We've chosen the utility task vehicle market to go into, UTV for short. Maybe you're not familiar with UTVs, maybe you're more familiar with ATVs. UTVs are the largest, fastest growing, and highest margin segment of off-road vehicle, and they have the most commercial applications. By choosing the largest segment of off-road vehicle, we can repurpose our R&D to serve the larger power sports market, which is about a $40 billion market, growing to $50 billion in the next 5 years. We have 3 distinct customer segments with unique strategies. We have recreational customers, we have small businesses, enterprise, and military and defense. All of these customer segments experience the same issues. Combustion powertrains lack reliability in these vehicles. There's high level of pollutions in terms of CO2 emissions, spent oil, and noise pollutions. And electric vehicles would solve all of these, but there is a lack of electric options in the market. The broader market has showed indicators that it's moving in the direction of electrification. These multi-billion-dollar existing manufacturers all have dedicated resources to electrifying their products, but they've outsourced R&D of their powertrain technology. Polaris recently invested $60 million in Zero Motorcycles for R&D of the powertrain of their off-road vehicles. Another startup, Vulcan, just received $100 million in pre-orders for their electric UTV. And over the past 10 years, $632 million has been invested in electric off-road startups. However, the strategies of these companies are flawed. They all promise to do a vehicle right off the bat, which means years of cash burn before you make any money. You have to develop the programs. That's the exact reason why SPM is going to be successful, because we have a strategy that makes sense and gets us to market in less than a year. We're focusing on IP ownership of the powertrain, bringing it all in-house, and we're actually developing an EV conversion kit for the millions of combustion UTVs in the worldwide fleet, which allows us to get to market in less than a year with less than $500,000 invested. We can then roll that momentum into a ground-up powertrain development and vehicle development, which gives us the flexibility of either selling direct to consumers or licensing our IP to some of the OEMs. This strategy has actually had a lot of traction in the past 6 months. We've raised $170,000. We have an ongoing partnership with an OEM, and we are in contact with 3 government contractors that upfit UTVs for government use cases. This might sound ambitious, but this has been my life for the past 20 years. Growing up in Western Pennsylvania, I've owned every type of off-road vehicle. I was an ATV and a UTV designer at Honda Power Sports, and also was one of the lead mechanical engineers on the Tesla Cybertruck. The founding team is equally as credentialed as me. Every member of the founding team actually started their own company developing one of the subsystems that goes into the powertrain in our vehicle. So this is the dream team, handpicked. And we also have an ex-Polaris executive who believes in what we're doing and think it has a lot of potential. So who's ready to build the next off-road vehicle brand here in Pittsburgh, Pennsylvania?
Is there an issue in terms of overlap of existing EV charging capabilities with the markets where UAVs are used?
So right now, there is a lack of charging infrastructure for off-road vehicles. We're designing our vehicles with Tesla NACS charge port, so you could use the supercharger network. with our vehicles, but that's actually an adjacent market we plan to service in the future is to set up these charging infrastructures at the largest trailheads in North America.
And given that, where do you see, who are the early adopters going to be in terms of the retrofit? Like, what is the use case that you're targeting there?
Yeah, so we actually have multiple segments who want to retrofit. Right now, the most prospective has actually been UTV upfitters for the government. So you have these partners who buy UTVs, they fit them with autonomy, hardware and software, and then they sell them to the government. They're actually interested in our EV powertrains because it's easier to control, it's easier to maintain the powertrain, less maintenance, no noise pollution, and there's no heat signature. So it's a lot more stealth capability for the military.
When you think about your design targets and the functional spec, like what's going to differentiate you in your powertrain product? Are you trying to be the longest range, the most rugged, the quietest? What is the advantage?
So the way to make an impact in this market, you have to go in highest performance. You really have to get that virality aspect so that you can leverage the network effect, get people talking about your products, doing reviews on your products, partnering up with social media influencers who have millions of subscribers to get in front of the eyes of the right audience. So we're really just, with electric, it's easy to be higher performance than combustion. So that's kind of the easiest thing for us.
I guess, where's your IP? Like you're retrofitting, I assume you're using existing lead acid battery packs or maybe NMC if you're going high power, but your innovation is going to be on the powertrain and the motors, or where is it?
Yeah, so our innovation's on the full powertrain. So we have IP in the battery pack. It's an in-house design. We're going to have IP on the drive unit. So that's the motor and the gear train combined. And then we have the embedded software and the controls for the whole system. And then in the future, we'll have some power electronics IP as well. This strategy has been seen to really attract the OEMs who want to outsource their R&D in the past.
And then for the manufacturing of those, are you using like a Jabil or a Flextronic? Like what's your process to making these powertrains?
So to start off, the conversion kits, we'll probably make them in-house, but we've been exploring contract manufacturers.
All right, just a gentle reminder, if you're an investor in the room, spots are filling up in these one-on-one meetings, so please scan that QR code and begin signing up for them. But in the meantime, we are moving on to Cloopify.
Hello, everyone. My name is Daniela Ocio. I am the CEO and co-founder of Cloopify. We're empowering enterprise organizations to become engines of resilience, profitability, and sustainability. But let me tell you a story. I'm building the solution that I wish I had when I worked at DuPont. Right, I managed $600 million of spend, and they gave us some really Herculean tasks to manage our complex supply chain. And yet those existing systems really did not meet the task at hand. Until the pandemic, we didn't even know what a supply chain was, or at least the general public didn't know. And organizations weren't spending to digitize their supply chain, to gain the visibility into their supply chain. It's costly, and compliance really affects your supply base. You get no real actionable insights, and you're dealt with managing your supply chain via Excel spreadsheets and ad hoc systems. And that's why 62% of organizations aren't even engaging their suppliers, the thing that feeds their companies, where they're going to drive the most amount of value, and yet they have little to no visibility to the environmental impact, to their performance, to what's driving cost. And so that's why we've developed Cloopify. It's an all-in-one kind of sustainable procurement platform where you can assess your suppliers, you can drive decarbonization, you can manage your supplier engagement, all while leveraging AI in a way that doesn't think of it as some sort of silver bullet, but really understands the problem thoroughly and is applying that technology to solve those so that you can drive cost savings, reduce your risk, We always say at Cloopify, there's kind of three big things that we do. We're going to keep you off the Wall Street Journal for all the wrong reasons, right? We're going to enable you to be compliant with these regulatory frameworks, REACH, ROHA, CBAM. It's an alphabet soup of things, and guess what? The majority of your data you need to get from your supply base. And third, but certainly not least, during the wonderful, let's say, pandemic, 98% of all S&P 500 companies made these very aggressive, net neutral, reduce my carbon footprint. But similar to you are what you eat, for a company, you are what you buy, and where we had little visibility. So we drive you through that entire decarbonization journey, giving you visibility into your supply chain. And listen, we've gotten some really exciting product market fit and traction with some of our early adopters, as well as some of our largest enterprise clients in the pharma space. We have 100% retention through all of our clients. We have 500% ACV growth since the start of launching Cloopify. And when we've gone head to head against the incumbents in the space, our technology and our platform wins, right? And that's why even in 2025, the beginning of 2025, we saw 144% growth in our total contract value. These numbers speak for themselves, which is why we're so confident in our product market fit and now are focused on scaling. We just brought on our first kind of executive leader, and we've committed to doing 1,500 supplier assessments. If we convert only 1%, a conservative 1% of those 1,500 suppliers into clients, that is $1.2 million of annual recurring revenue, in addition to what we're doing with our direct sales. And man, oh man, do we have an exciting pipeline. Our top of funnel is filling through direct sales, through our executive leadership, or through our executive sales leader. But we also partnered with the largest the largest association of procurement professionals, the Institute of Supply Management. We've got a fast-moving bottom funnel, active pilots. We've got about 300,000 of annual recurring revenue, and our contract size is about 144,000. We've got a unique procurement-focused approach, which is giving us market industry coverage. And this industry is a huge market, $1.6 billion, growing 20% annually, which is a really exciting opportunity for us. Now, I'm not going to bore you into all the specifics, but we've got subscription and scalable with compound growth as we monetize our supply base. Which is why when we just launched with our largest organization, they said, man, I asked for a Pinto, but Cloopify gave me a Ferrari. Didn't think I could blush from a compliment on our tech, but I definitely did. We've got a dream team to support that, multi-exited CTO, CSO that has launched organizations with over 300% business growth. So we are really the dream team to make this come to life. We're raising a $3 million seed round, but the bigger question is, are you ready to make history together? Thank you so much.
Just to start out, how do you actually validate the data from the supply chain such that they're firm enough that they could be used for regulatory findings or carbon credits or other things along those lines?
So there's a variety of ways that we do that. One, instead of sending suppliers blank questionnaires, we pre-populate the questionnaire based off of publicly available information. We do a quality assurance test based off of what they said, as well as what the market kind of industry data points are. And we ask for supplementary evidence. So third-party validated, like audited, validated information that gets tied back to the data that's shared. So there's always a data flow, and there's one centralized place where you can manage all of your evidence to be able to share it with your environmental health and safety team, have confidence to comply with those regulations.
Are you working with consultants who sell into these companies?
Yeah, so we've got one of our first early consultants that partnered with us is a company called Kearney. I worked with Kearney whenever I was at DuPont. They managed the Dow-DuPont merger, and so grew a great relationship with them. And now we're one of their strategic partners. So we're part of their ecosystem. They're bringing us into deals, as well as associations are bringing us into deals as well. So we've got a kind of multi-pronged market approach.
Is there an industry that you're choosing to focus on initially?
Yeah, we're seeing a lot of buying signals from the pharma space as they are a reputational industry, especially if you have something going on in your supply chain. They're the first ones to get affected, so they really need that visibility into their supply chain, as well as manufacturing organizations, where up to 80% of a company's footprint comes from their supply chain. And so they're very desperate to get that visibility and to digitize their procurement processes, supplier engagement, enablement processes. Thank you.
Next in the showcase, we have Module.
Good afternoon, everyone. Just fresh from our factory, so I'm not dressed for the occasion. Headed right back to the factory. So at Module, we truly believe that everyone deserves to live in a well-designed space they call home. And the day I had today really made me question if we want to live by that, but we continue to live by that. If you're not familiar with the looming crisis that's here and continuing to get worse in the housing industry, we're short several million homes, depending on the source. We have an aging workforce, and we have a very wasteful industry. Module's approach to this three-headed monster, we call it, is modular housing that's sustainably designed and manufactured, inclusive of the community that the homes are being delivered to. If you aren't familiar, modular housing is constructed in a factory setting, similar to thinking of a stereotypical manufacturing line where your sub-assemblies are put together, and then in our case, put together as fully volumetric boxes where we then deliver the boxes to the site, and with the crane, they're set onto your pre-built foundation system. And for simple terms, think of a floor as a box, so you're just stacking Lego blocks. We started off as just a design firm, but realized by just being design, we had limited control over quality, which was the main driver for us to become fully vertically integrated. But in addition to being able to better control quality, we now have a much higher margin profile than we would as just a design firm. So we're significantly higher revenue and higher margin. And this also gives us a complete feedback loop as we think about developing the product, which we're at the pillar. Our pillars are space efficiency, so thinking about urban context, energy efficiency, and then cost. So those are the three factors that we consider as we continue to develop the product. We think about missing middle housing stocks, or anything from an ADU to a 2,000 square foot single family home or multifamily, anything in between. And we design everything to the baseline of the Department of Energy's Net Zero Ready Energy Home Program, but in regular speak, that just means our utility bills are significantly lower than other homes and better for the homeowner at the end of the day. And right now, we have delivered homes in Pittsburgh. We're actively looking to expand our footprint based on our product-led strategy. Our team's built of designers and product designers and product managers. And so we think about our homes as a set of standardized components that we can assemble, several different ways, a bunch of permutations. And we've taken a newer approach to modular and surrounded ourselves with industry veterans who are helping us continue to scale our operations. Right now, our pricing is competitive with stick building at a head-to-head when we're thinking about the same exact product, but where we have the advantage is speed. So your carrying costs for the project are significantly lower, and you're de-risked because you have less to manage on site, because 80% of the project is done at the factory. We primarily work with affordable housing developers, whether that's developers, nonprofits, housing authorities, although we still work with market rate developers in this current climate, a lot of those projects do not pencil, and we found it's made our business stronger because these projects that require subsidy are the only ones that are really penciling these days. And what has really allowed us to take off is opening our factory last year. A lot of modular factories are located in very rural communities where they're able to corner the labor market and drive down salaries, but we pay our people a living wage. We're right in Carnegie. You can come visit us. We have a tour on April 14th, and my email is going to be at the end. Would love, if you're interested, to come spend some more time with us, and you can come look at our houses. We are very proud of the work we do, so we invite people to come see what we're doing because we have nothing to hide, and I'd rather show you than tell you. But right now, we're in the middle of a raise. We have approximately $7 million committed, looking to raise an additional $2 million, which will help us take on larger scale products so we can front material purchases up front. If you liked what you heard today, feel free to reach out. And like I said, we host a tour, so email me if you want to come or if you want to see our homes. We're very proud of what we do. Thank you.
When you think of a building, the traditional process involves a lot of on-site inspections and process and integration with the city or the county or the township that you're building in. Are you guys able to get any efficiency or economy of scale on the bureaucratic aspects of home building and siting through your process?
Yeah, so that's where the majority of the time savings come from, delivery to the end of the project, which most of the inspections that are normally done are superseded by a state level inspection. Each state has a third-party agency that they use to perform the same inspections but at the factory, and they're on a much more rigid routine schedule where they are serving us as opposed to being at the mercy of your local jurisdiction. So we're able to shave months off of projects because all you have to do is get your finals on site. You don't have to get any partials.
Can you speak to a little bit about like the number of units you've built, the different sizes, your revenue?
Yep, so modules existed for 8 years, but really existed for about 2 years now and like really went for it. So we did about $5 million in revenue last year. We'll do about 7.5 this year. It took a while to establish product market fit, and eventually, this is why I joined the company. They took things in their own hands and just developed projects as Module being the developer. And then once we had actual homes to show, that's when the company really took off over the last about 2.5 years. So we've done about 25 homes. We have about 70 doors that we're going through permits right now, and we have 15 units lined up between the next 3 projects, including an expansion into the DMV market. We're doing an apartment building in Richmond, Virginia. Cool.
Next up, we're going to hear from Reclamation Factory.
Hey everyone, I'm Georgia and I am a robotics engineer and the founder at Reclamation Factory, and I want to tell you about our plan to turn your trash into valuable new products. I don't think I need to tell this room that plastics recycling is broken. In the United States, we generate 40 million tons of plastic every year, but less than 6% of that is ever turned into something new. At the same time, manufacturing demand for recycled plastic is on the rise, and in 2023, we actually had to import recycled plastic from other countries to meet that demand. So if there's such an acute need for recycled plastic, why is so much of ours ending up in the landfill? It's because our infrastructure was never set up to reclaim plastic. It was set up to collect trash. Right now, Our plastic processing capacity is less than 10% of generation. That means that even if everything you threw out is perfectly clean and sorted, we have the ability to turn less than a tenth of that into something new. And at the same time, it's important to remember that, experts agree that we're not going to have the infrastructure that keeps up with our plastic generation and recycled plastic demand. And ultimately, rural and small manufacturers and generators are going to be the losers in this equation. And I know this personally because I used to manufacture with recycled plastic, or I tried to. Before starting Reclamation Factory, I designed and 3D printed small dwellings, but I struggled to find a source material that was sustainable. We were much too large to be recycling our own plastic and much too small to be interesting to the large processors and recyclers. The small but mighty team at Reclamation Factory wants to change this. And we're doing that by simplifying and expanding our plastic recycling infrastructure. We are doing that by taking your trash and turning it directly into products that are valuable for domestic manufacturing, like flake, pellet, and extruded form at the point of generation. We're developing an automated, modular, and intelligent plastics microfactory that can be distributed anywhere where plastic waste is a problem. This microfactory is going to really connect inputs to outputs, make really well-traced plastic recycling to support and expand our current plastics recycling infrastructure. Right now, the plastics recycling and plastic resin production markets are huge. Post-consumer plastic market in particular is a $6.5 billion market that is expected to double by 2032. We're focusing in on the tri-state regions of West Virginia, Ohio, and Pennsylvania, and we see our immediately addressable market size as $1.5 billion, and this is just on our post-processed offtake side of the market, and not yet considering the potential market size for waste collection. Like any waste management company, we make money by collecting trash. How we are different is we are skipping over the brokers, the storage facilities, the transporters, and the post-processors, and selling that valuable manufacturing source material that we produce directly. We're focusing in on communities and campuses of 10,000 people or less, and supplying them with detailed diversion reporting. And on the offtake side, we're focusing on small manufacturers and providing them with a fully traced recycled product that has a compelling local story. We spent the last year really proving out our market on both sides of that market. Right now, we are part of the PGH Lab 10 program, and we are working with Pittsburgh Department of Public Waste to identify some sources of hard-to-recycle plastic and find potential diversion pipelines for them. We are also operating an identification and size reduction pilot with a local plastic recycler, Reimagine Recycling. Thank you so much for your time, and looking forward to your questions.
Will you be able to handle mixed waste streams, or do you require, fully separated plastic?
Initially, we're focusing in on mostly separated plastic, so fairly specific waste streams, and mostly verifying that anything that comes into our pipeline is what our manufacturers on the other side of the pipeline expect it to be. In the future, though, we would really like to be dealing with more mixed waste streams and being able to process multiple types of plastic.
In terms of the form factor and the composition of the offtake, how easy or hard is it going to be to get a customer that's going to accept what your modules make?
Yeah, like I said, demand for recycled plastic right now is really high. PET and polypropylene in particular are seeing spikes. What is most important to most manufacturers is that material is to spec, so that there isn't a lot of contamination or other plastics, and also clean. So meeting those two requirements with our technology is well within our capabilities.
And your goal is to create a fully integrated and automated solution. You've had a depiction there. How far away do you think you are from realizing that?
I think we're a few years away from realizing that full pipeline. However, just the initial part of that pipeline, separation or identification and size reduction, which is a huge part of the market, we are just a few months away from some of our first pilots with those two consolidated and automated processes. Great. Thank you, everyone.
Next up, we have Sabana.
All right, thank you so much for having me. My name is Ren Quesada. I'm very excited to tell you more about Sabana. Soul-sucking, wasted time, blood, sweat, and tears. We've talked to over 100 architects and engineers, and they're all saying the same thing. They hate writing construction specifications. You probably don't know what these are, but when you're building a building like this, not only are you doing the drawings, but on top of that, you're also writing a project manual. Those contain the specifications, just like these, can be hundreds to thousands of pages that describe in detail the products and the materials to go to every building. Not only are they extremely tedious, but they're very important. These are contractual documents, so any potential discrepancy could lead to a liability exposure. After working in the architecture industry for nearly a decade, I realized that this process is a mess. You have a lot of different team members looking through products online, saving them into folders, renaming the PDFs, emailing each other, using phone calls, chat, just to get all these changes onto a spec book, where a technical lead basically grabs all this information that is unstructured, reviews it, and puts it in technical language. Puts those, ultimately, the majority of firms still use Microsoft Word. Not only is there a lot of slow manual input, but it's prone to human error. So we decided to work on Sabana. We're an AI data management platform that helps architects and engineers specifically through this process. We try to save time, increase your revenue, and minimize errors. So let me show you how it works. Let me see if the video goes through. Okay, video did not work, but that's okay. Basically what we do is we let any architect or engineer upload any product from a URL. Through that, we're able to use our AI to scrape the information and then grab parts through all the parameters and get that information in a structured system so you can actually compare products from different manufacturers. At the end, you can actually take this and then export it into a spec book or a spec sheet, and then that way architects and engineers can collaborate through that process. So how does this tie to Energy Week? We think that there's a lot of potential in us parsing through the information and actually downloading a lot of the environmental data that is associated with these products and materials. That includes EPDs, environmental product declarations, health product declarations, material sourcing certifications that can really help architects and engineers make a decision of which products should actually get spec'd. Even though we're very early, we're a student startup, I wanted to highlight a specific example from a use case. This is one of those architecture firms that I love. They actually went through the effort of carefully reviewing each product option and material, and by doing so, they actually were able to lower their embodied carbon by almost 60% in comparison to a typical baseline. And this included efforts from structural engineering, architectural, and MEP. When you start looking at the embodied carbon of buildings, if you're able to make those decisions early on in the process and be really careful about what you're speccing, you actually could use biogenic materials that capture and sequester carbon early in the process. So you start at a negative, and ultimately down the road, you can really decrease your embodied carbon output. In this example, 94 tons versus 24 tons for 50 years. The team is myself, Saka Kulkarni, and Alex Ju. They're full stack engineers, students here at Carnegie Mellon. We actually started our company last summer. Since then, we've talked to over 100 architects and engineers. We finished the TechSource Accelerator, and we're actually onboarding our first few beta testers. We have a few firms around the United States that are testing the product right now, the very lean MVP. And we're hoping to actually, at the end of the month, have a new product, a new second version with a lot of the feedback that they've been giving us, and hopefully we can get them as paying customers. We also have 22 firms in the waitlist. Thank you so much, and thank you for having me.
So in the design process, in many cases, you know, I'm a mechanical engineer, so forgive me. So SolidWorks, Creo, Dassault, Autodesk. Oftentimes, the PDM software defines a lot of this, or it catalogs a lot of this information, and then what you've spec'd into the design often is 3D modeled or 2D modeled into the actual design. So I'm kind of curious, how do you integrate with the actual you know, defining design documents vis-a-vis the 3D model or 2D prints generated from them?
Yeah, absolutely. I mean, we're hopeful that we can make a product that can actually go back and forth between BIM and having a spec book, because ultimately a lot of these are not very automated. Also, one of the challenges that we've been talking to a lot of our users is that even though they're using BIM, a lot of the information inside of the models actually not end up being that accurate, or there's a lot of changes and they don't keep up. So their spec writers are actually scrambling through all this information. What we need, or what we're trying to do, is have a lot of clarity through the entire process in one place. But we do see potential in actually helping or figuring out a way to integrate or use a different tool that helps us do that. Like, for example, for BIM, there's a company called BIMlink. You're able to put that information onto Excel spreadsheet and then populate the components inside of a BIM model.
And what do you envision being your business model?
Yeah, so we didn't get into that, but currently right now we're looking at pricing per seat. It's still very basic. We're trying to attract small to medium-sized architecture firms in the region as our first starting point. We think it's a good starting point for us as we're starting to create a product and then ultimately try to attract some of the bigger players. But we want to start with a very simple pricing. Firms up to 4 seats, around $500 a month or $550, and then up to 9 seats for $1,200. Thank you.
All right. We've heard from a few investors in the room that they're having trouble signing up for the one-on-one meetings through the Google Doc. If you are having trouble signing up for meetings, please see Caitlin Haas-Conrad. She's going to be down in the Conan room. She's raising her hand right now. She will help you get signed up for those meetings during the break, which will be happening in about 15 minutes. So next up, we have Viaduct Innovative Technologies.
Good afternoon. I'm Jay Hewitt. They say you're supposed to start these things off with a problem. I'm actually from West Virginia. We don't like problems, we like stories. So I'll give you one of those and you can go from there. So you guys, yins, as y'all say, have a lot of natural gas in the area. You got a lot of wells down in Greene County. That methane is shipped down to the Gulf via pipelines. They take about 15% of that total methane and it is used to compress it to even get it there. It's then used in ammonia facilities. They break it apart, use the hydrogen, a little bit of nitrogen from the air, and they make ammonia. They then take that ammonia, ship it back up to us, to local areas, and out to the farmer. So ammonia is fertilizer. So all that, why do they do that? They say it's more efficient. We'll get to that later. So this is our team. We're actually out of WVU's lab. We have about 16 patents. The man on the far right there, he is the one with all of the genius, and his first student was Brandon. They brought Kim and I in, do the business aspect of it, and be the monkey banging the cymbals up here for you. So what are the current challenges with ammonia? Well, it's about 2% of the world's emissions, all right? It is used in almost everything. It is the second most used chemical in the world, but it is very centralized. A single facility costs about $6 billion to put in, and about 10 years to put in. Just more on the ammonia and what uses are for. What is our advantage? Well, we are more efficient we are currently at lab scale, and we are more efficient than the big boys are at scale. How we do that, we have lots of patents that say how we do that, but mainly it is we do it at lower pressure. They need 4,000 PSI. We can actually do it at atmosphere. So I told the boys, you tell me you're going to break this molecule in half, take the hydrogen and make ammonia. What are you doing with the carbon? Oh, we have something for that. Carbon nanotubes, industrial scale, $100 per kilogram. Way to bury the lead, fellas. There is more money in this than the ammonia. So carbon nanotubes are pretty cool. They get used in space programs and cell phones. A lot of stuff high-end. If it needs strength, it needs to be light, you need a carbon nanotube. We believe we are in this range, and we believe we can make about a ton of this stuff a day. Now, a kilogram fits in a 5-gallon bucket, so it takes up a lot of space. Our advantage, we use microwaves. We heat just the catalyst, not the air around it. We use a lot less pressure, and we're more efficient. So we actually use electricity to make the reaction occur through the microwave. Any pass-through, we're actually going to generate our own electricity on site at a well pad. That gives us a great advantage. The pass-through would be a hydrogen-methane mixture that we would use to burn and create the electricity that we need. Funding, we've actually already passed our seed stage, and I do have an announcement today that we are going to our Series A today. We got $1 million safe from NeoTribe. That is the co-founder of WebMD. He has a VC company. We are looking to raise about $12 million in this first one. That will be our pilot project that will go on location. Thank you.
So just to understand, you're ingesting methane, you've got a microwave-based thermal pyrolysis process, and then you're making ammonia somehow? Is there any?
So we break the methane, you get hydrogen and carbon. Carbon goes to the carbon nanotubes. The hydrogen, we pull some nitrogen out of the air in a separate reaction, and that creates ammonia.
And on the ammonia side, is that also a microwave-enhanced reaction?
Yes, it is.
Better than traditional Haber-Bosch?
Correct. So we use a microwave, the same microwave for both processes. So we can use the same generator, same microwave, just 2 different reactors.
As you noted, Haber-Bosch processes, like these tend to be very big, very large, expensive plants.
Mm-hmm.
Up there, I thought you said a 50% reduction in CapEx. Maybe is that 50% compared to a traditional Haber-Bosch, or can you just walk me through that a little bit?
Okay, so traditional Haber-Bosch, real expensive, like $6 billion. They have to have really thick walls. You remember that 4,000 PSI, right? I can make this stuff in glass. Okay, so that capital you need to create the ammonia is a lot less, and the energy and amount that goes into it is 14% less. So you have the capital reduction up front, and then you have the daily operations also reduced.
And what scale have you been operating at right now?
We are in a kilogram stage. When we get to the pilot, we'll be in the ton stage.
And that's kilogram of ammonia production or kilogram of separation?
Both, actually.
And then also just a little bit about like your quality, purity, and how that compares to industrial needs or standards.
So carbon nanotubes are a little weird. There's not really standards on it. It's almost custom fit to who you're selling it to. So it's a bit of a niche market. But we believe we can make a branched carbon nanotube that is industrial grade.
And just ballpark, where would you expect to be on cost relative to market price for ammonia in the region?
I actually did my economics on $10 a kilogram for the nanotubes and about $700 on the ammonia.
Thank you.
All right, big kudos to everyone for staying on time. We're only off by 1 minute for this very ambitious schedule, so great job, everybody. Last but not least, we have ESTAT actuation.
Hi, everyone. I'm Stuart Diller, CEO of ESTAT Actuation, and our hardware is the key to reducing the robotics energy footprint. So much of our equipment and machinery now is powered by pneumatic and hydraulic actuators. And these are primarily because these can be fairly high power density. In other words, lots of mechanical power for a relatively small package. However, these actuators are massively inefficient. So worldwide, they consume 59 quadrillion BTUs of energy every year at a 22% average efficiency. So that translates to 46 quadrillion that are just wasted heat, completely useless. And this corresponds to $500 billion in energy costs. So the industry is highly motivated to mono-energize or to move toward just using electricity in these systems. However, there are some substantial practical drawbacks to using just electric systems. So here's an example of a fully electric robot arm in a factory, but you can see that it's got these really big joints that are full of these motors, brakes, and gears. These are big and heavy and expensive relative to the less efficient alternative, and it translates to systems that are correspondingly big and heavy and can't safely operate around humans, and it's really difficult to translate these into mobile applications outside of the factory where they're bolted down to the ground and plugged into the wall. This is where ESTAT's technology comes in. So we've created a fundamentally new way to do this brake component. It's still electric, but instead of being electromagnetic, it's electroadhesive. And this corresponds to orders of magnitude improvement in performance on each of the key metrics that these customers care about. In particular, the torque per weight, the torque per unit size, and the torque per unit power consumption. So these order of magnitude improvements are similar to the kind of order of magnitude improvement you saw from going from transportation pulled by animals versus transportation pulled by motors. And this is what our customers are able to see in their designs. We are the technology developers and experts, and we have a strong IP patent portfolio around it. Just to drive the point home, here's a customer use case of a customer who's building an urban mobility system. They have 23 joints and require a brake in each of these joints for safety and for energy efficiency reasons. Using a conventional brake is really not a good option because, as you'll see, when they replace conventional brakes with our brake, they're able to effectively remove the weight of a bucket of cement from this system, 23 inches of total joint length, and enough power to run a small refrigerator. So this really is the difference for them in whether this product can be viable to be a fully electric system or not, or whether they have to go with the energy inefficient alternatives. Our obtainable market, just based on applications we've already qualified with customers, is over $100 million. And that's a small portion of the total addressable market for these actuator systems, which is really where we see the big opportunity to decrease carbon emissions and decrease the energy that they use by going with electric actuation. In terms of competition, there are basically two groups. There are the conventional actuator manufacturers that build these electric actuators. Honestly, they're very, very good at what they do, but they've eked everything they can out of that conventional technology and can't facilitate these remaining applications for this conversion. So really, that makes them more of customers and partners for us, because by working with us, we can give them access to these markets. There's also a group of startups doing legitimately new things, but we're the only company in the world building and commercializing electroadhesive brakes that have this fundamental performance. We have an excellent team with deep technical and industry knowledge. We're all CMU graduates, and we're doing hiring. So both on the commercial and the product and engineering side, if you know people, please send them our way. And finally, we're raising a $5 million investment now that could have up to a $9 million impact for us through matching through our non-dilutive sources. And we're targeting that for investment into growing our commercial pipeline, having the capability to deal with more than just a few customers, and the R&D and product development around customer interactions. So thank you, and we're powering the next robotics era.
Could you speak a little bit to your cost position versus the market incumbent and also your ability to integrate into the full system?
Certainly. So this is a really exciting aspect of our business that's growing right now is we're working with contract manufacturers and getting costs substantially down. All of our components in our designs, you can see, are 2D components. So they scale incredibly well compared to the conventionally machined components that go into the conventional designs. So boiling that all down, right now our margins are around 75% with a premium price point. Within 5 years, we want to drive down to a price point that's much closer to the conventional, but still maintain our 50% margin.
And then the integration piece about the overall system design and how much work has to be done to switch to using your brake technology.
Some of our solutions are directly drop-in. We have a few demos where we just show conventional versus ours, plug it in, see the savings.
In terms of the power supply requirements, are they generally similar to an electromatic or different? And just, again, following on to Josh's question a moment ago, and then secondarily, is regenerative braking an option or not an option in your architecture?
Good questions. On the power support electronics side, we're actually nicer to deal with than the conventional versions. So our electronics are about the size of a stick of gum, compared to usually it's more like the size of a book for the conventional systems. And then, sorry, could you remind me the second part of your question?
Regenerative braking, is it?
Regenerative braking. Right now, we're focused in just on the holding, locking, and speed matching tasks. In the future, there is opportunity to develop this into more of an integrated actuator system that could capture a lot of that energy back and return it.
And then, do you have durability data?
Yes, so we've demonstrated over 1 million cycles and hundreds of hours of operation. We're currently in the process of qualifying 2 particular customer longevity specs through accelerated testing. Demonstrating 10,000 hours takes years to do, so we are using accelerated, harsher versions of the testing to demonstrate out for those customers.
Thank you.
Thank you.
All right, that was quite a journey. Let's give a big round of applause for all of the startups that have pitched today.